In this lecture, we will give you an example of a surface mount resistor in size 0805. This is an illustration showing a construction of a surface mount thick film resistor. As you can see on the picture, there's a resistive element on top of the resistor. Electrons are shown as terminals on both sides. And also you can see the aluminum substrate. On the top of it is the protective coating. This shows the basic information from DG about 0805 10 kilo ohm 1% surface mount resistor. It shows a brief description as shown here, and also a detailed description including a basic information about this resistor. This resistor is automotive qualified with AEC-Q200 qualification. Now let's go to the datasheet of this resistor. On the first page, you can see the basic information about this series of resistor. It's called standard thick film cap resistors. If we scroll down, you can see the technical specifications. This is a general datasheet for resistors in different sizes from 0402 to 2512. Resistance tolerance is 5% for 200 ppm per Kelvin, and 1% is for 100 ppm per Kelvin. The operating temperature is ranging from minus 55 degrees C up to plus 155 degrees C. The permissible voltage is the maximum allowed voltage over this resistor for 1 minute. Usually, the working voltage must be much lower than this value with a good derating factor. This slide shows the temperature coefficient and the resistance range. Note that E19 is corresponding to plus minus 1% tolerance. This is the packaging for the different types of resistors. This is the part number and the product description for ordering. Now let's go over a few graphs in the datasheet. The first graph is about single pulse. This log-log plot is the maximum allowed power pulse, Pmax, versus pulse duration, Ti. This is a single pulse condition that the average power over time is 0. This plot is the maximum allowed power pulse versus pulse duration, Ti, under continuous pulse condition. That means the pulse power is periodic, given the condition that average power must be less than the permissible power dissipation rated at the ambient temperature. This graph shows the maximum pulse voltage over the resistor given a pulse duration for both single and continuous pulses conditions. This graph shows that the power derating should be considered if the ambient temperature is over 70 degrees C. And each curve represents different sizes of the resistors. Non-linearity. This graph shows the non-linearity of the resistor in terms of the attenuation of third harmonics parameter A3 versus the resistance value R. If the resistance contains a nonlinear element, the Ohm's law is no longer valid. This is a block diagram of a basic experimental setup to measure the nonlinearity of resistor. For convenience, the third harmonics is used to measure parameter A3 because the third harmonics has the largest magnitude and therefore it is easiest to measure. This graph demonstrates that the attenuation of third harmonics A3 drops as the resistance goes up. That means as the resistance goes up, the resistor becomes more nonlinear. This slide gives a basic working knowledge about noise generated by resistor. So normally there are two types of noise coming from the resistor: thermal noise and current noise. The thermal noise is also called the Johnson-Nyquist noise. Thermal noise is constant over a wide range of frequency, like a white noise. Current noise, on the other hand, is excessive noise generated when current is flowing through the resistor. The noise is an unwanted phenomenon for resistors. Current noise is a relative noise voltage on the terminals of fixed resistor caused from the DC current through the resistor. As you can see in the graph, it is expressed in microvolt in RMS voltage per volt in DC. You may want to pay attention to this graph when you are working on precise and low noise circuits, when the measurements is only a few microvolts. In datasheet, the test procedures and the requirements are specified in the following tables. Please go through them by yourself if you're interested. This is another table for test procedure and the requirements. Here are the references for this lecture. Thank you and see you next time.